Hello friends. So we are in this our session. Now we will design Norton's theorem on the platform of Tinkercad. So similarly, we are having Thevenin's theorem that we have discussed in our previous video. So the Norton's theorem, it states that any given bidirectional network can be converted into its Norton's equivalent circuit in which it consists of short circuit current source ISC in parallel with Norton resistance Rn across the load resistance Rn. Okay. So here we will design our Norton's equivalent circuit for this given circuit. So same here we will design on our platform Tinkercad. So here we are considering RL as a load resistance R4. Okay, so now let's see. So regarding this, here we are having our platform Tinkercad. So now similarly, we are having a breadboard over there. Now we are working on power supply source, that is your DC. So I will rotate it accordingly and I will connect into the breadboard with the help of resistance. So we are having four resistance over there. So this is my resistance R1. So I am connecting R1 over there. Similarly, resistance R2. So from the same point here, we will connect our resistance R2 over there. Now my next resistance, that is for R3. So it will be connected on the same common point over there. So it is basically called a node or junction. Okay. Now next that is your resistance R4 is over there. So this resistance I will consider as load resistance. Okay. So our first step will be that we will identify our Norton's resistance Rn. So similarly, we will process if we are having voltage source, so we will keep short circuited, and we have current source, so we will keep open circuited. So in this case, I am going short circuited from here to here. Now we are having low resistance R4, we have to keep outside, and we will mention over there, which is our low resistance RL. Now, to identify Norton's resistance, we will give our multimeter over there and I will connect accordingly my first terminal over there and next negative terminal to the resistance R2 as it is in horizontally shorted. Okay, so you may also change the color accordingly. Now here we need to identify the resistance. So we will keep resistance over there and we will identify with the help of simulation. So here we got it our Norton's resistance 1.5 kilo. Okay, this is the value of our Norton's equivalent resistance. Now here we have to identify short circuit current. So for the short circuit current, we have to disable this wire and now we will connect our positive terminal to the first terminal of resistance R1 and the negative terminal to the next terminal of resistance R2. Okay. So multimeter here we are using for the measurement of ISC short circuit current. So in the previous circuit, you can see that resistance R3 and R4 both are connected in series. So means same current will flow. Okay. So here we have resistance R4, that is your 1 kilo ohm, and R4 is working as load resistance. Now here we need to identify the value of current. So we have to change the mode of multimeter from resistance to amperage, and after that we will start a simulation. So now you can see as all the value of resistance are 1 kilo ohm. So now we got it ISC 3 milliampere. So we got it the value of ISC 3 milliampere. Norton's resistance, that is your Rn 1.5 kilo ohm, and load resistance Rn is 1 kilo ohm. So now, with the help of formula, we will identify the value of load current. So now here again, we are having the formula over here. IL is equal to ISC into Rn divided by Rn plus RL. So with the help of this formula, we will identify the value of load current. So which is the analysis of Norton's theorem. Thank you.